I'm Miss Martin. I'm going to be taking you through your second lesson this week, which is a chemistry module. But before we start, same things. Please make sure you've turned off your phone, put it in a different room, just make sure it's not going to distract you. Please make sure you don't have any other tabs open on your computer. Make sure you answer all the questions in the booklet, which you should have in front of you. You can find that in the continuity of learning area of the John Smeaton website in the science area. And you can always rewind the video to re-listen to any information if you're not sure. And you can also use things like BBC Bitesize and other videos on YouTube to help you out as well. And obviously, don't give up until you've answered all the questions. We will be going through all the mark schemes to help you out if you do struggle, but please make sure that you're giving it your best shot. So this topic is going to be about the Earth's atmosphere, and we're going to start off today talking about the modern atmosphere. In terms of an overview for this topic, we're going to be talking about the atmosphere in terms of the layers of gases surrounding the Earth. We're going to be talking about the atmosphere changing from the distance of the Earth in terms of when you go up, how does it change? We're going to be talking about the fact that the atmosphere is a fluid and it can flow, and it protects us from dangerous radiation from space, and it's the reason that the Earth's warm enough to allow life to survive. We're going to be talking about how it's constantly changed over time, talking about when the Earth was first formed up until today, and how climate change is constantly adding to that change as well. Obviously, climate change being a man-made problem, and there's some natural cycles as well. So now is on page 1 in your booklet. What I would like you to do is I'd like you to compare the atmosphere in the questions using words like more, less, bigger, increase, decrease, and what you also need to do is I'd like you to quote data from that information to back up what you're saying. So if you say nitrogen has increased, say by how much using a specific figure from the graph. So pause the video for as long as you need to, and we're going to mark it on the next slide. So what you should have found is that the Earth's early atmosphere had much higher levels of carbon dioxide. There's less than 1% of carbon dioxide in the atmosphere today, which is probably much lower than you would expect. In the early atmosphere, there was no oxygen. That's gone up to about 21% today. There's much less water vapour in the atmosphere today compared to the early atmosphere, and that's because we now have oceans. The early atmosphere also had lots of ammonia, but we have nitrogen in the modern atmosphere, and it's nitrogen which makes up the majority of the atmosphere today, being about 78%. Anything that you didn't get, please make sure that you improve it in a separate colour. And if it helps, I would write it down in a list of bullet points. For example, nitrogen in the early atmosphere was in the form of ammonia. However, nitrogen is now 78% of the Earth's atmosphere. So we've started off with the basics, but what we need to get out of today's lesson is we need to be able to describe the differences between the Earth's early atmosphere and the modern atmosphere. We've done that already. What we're going to do is we're going to go on to explain those changes, and we're going to explain them in terms of the formation of limestone, crude oil and natural gas as well. So when we're talking about the early atmosphere, we usually focus on volcanoes, because and when the Earth was formed, there was lots of active volcanoes which constantly erupted, and it meant the temperature was very hot. What it also meant is that there was lots of carbon dioxide in the atmosphere being released, and it was also too hot for water to exist as a liquid, so a lot of the atmosphere was made up of water vapour. There was no solid crust of the Earth at this point. So the crust of the Earth, which you should know at Key Stage 3, is the solid layer around the outside. That would have been molten, it wouldn't have been solid like it is today. What we think, anyway, is that the atmosphere of the early Earth would have been very similar to what Mars and Venus are today. So you might get comparison questions for the atmosphere of Mars and Venus today to compare them to the Earth's early atmosphere. So when we're talking about modern day Earth, what we need to do is we need to think about the fact that now, obviously, it looks a lot different, but why is that? So, if you look at the picture strip on page 2 of your booklet, it shows how the Earth's changed from being a molten bowl of lava with toxic gases, so a lot of carbon dioxide, a lot of ammonia, to the modern day Earth. So what I'd like you to do is come up with a sentence to describe what is happening in each picture. So write it underneath what is happening on each picture. So you don't need to explain it. You don't need to say, why is that happening? You just need to say what is happening based on the pictures. Pause it for as long as you need to, but I recommend spending about 10 minutes on this task. So, how the Earth changed. So the early Earth didn't have much of a solid surface, like we said. It was hot, the surface was molten due to lots of volcanoes erupting at one time. The atmosphere was full of carbon dioxide, methane, and ammonia. Volcanoes also release water vapour and nitrogen into the air as well, just like the diagram states. So if you didn't get all of that information, please pause the video. Make sure you're adding it as we go along. This is the level of detail that you would be expected to come up with in a 6-mark question about how the Earth's early atmosphere has changed compared to the modern atmosphere. So, after a while, the Earth began to cool. So, less volcanoes were erupting, and that allowed the surface to solidify and form the crust as we know it. So when the temperature fell below 100 degrees Celsius, the water vapour was then able to condense and fall as rain. Because of that rain falling, this created oceans over a long period of time. It allowed rivers and streams to form as well. If you didn't get any of that information, again, pause the video, make sure you've added it. So we talked about the oceans forming. So it was a turning point in the Earth's history in terms of this allowed carbon dioxide to dissolve into those oceans. So the carbon dioxide dissolved into the oceans, and that allowed the carbon dioxide concentration in the atmosphere to come down. Some of the carbon dioxide in the water then reacts with minerals to form rocks like limestone. So that carbon dioxide has now been locked up into the limestone, so it's decreasing the concentration of carbon dioxide which is in the atmosphere. Again, please make sure that you've made any alterations that you need to. Pause the video for as long as you need to make these improvements. So, we're talking now about 2.7 billion years ago. Life started to appear. So we're not talking about life in terms of very complex organisms like humans. We're talking about single cells in the oceans. So bacteria, they're able to photosynthesize. And like we talked about in the biology lesson earlier, photosynthesis is where plants are able to make energy from sunlight. So when algae evolved, which is just a very simple plant, it began to remove carbon dioxide from the atmosphere as well. And photosynthesis, as well as taking in carbon dioxide, releases oxygen. And oxygen is really important because oxygen is what allows life effectively, because it allows respiration. So carbon dioxide levels fell. It was used for photosynthesis, and we've got lots of oxygen in the atmosphere now. So over the next billions of years, we're not talking about life evolving really quickly. It's a very, very long process. So we start to get plants over time. So oxygen levels continue to rise, and then we get animals after, we're talking billions of years after these plants have evolved and produced oxygen. Many of the early plants have become coal deposits, and this happens as they die. So they're covered in layers of sediment, which is mud. That mud rotted, and that allows for coal to form. Coal is what we know as a fossil fuel, and that is an example of how carbon dioxide is also locked up, so that locks up more carbon dioxide out of the atmosphere. Please make sure you get any of extra detail there if you missed any. So, key things. The Earth cooled and it solidified, and that is where the main changes started. So nitrogen was originally released by the volcanoes, and that is where the majority of nitrogen in our atmosphere came from. Water vapour condensed and became oceans, rivers, lakes. And the carbon dioxide became locked up, so it was removed from the atmosphere and locked up into limestone, as well as fossil fuels. Photosynthesis kick-started all of the life being able to evolve because it removed carbon dioxide from the atmosphere, and it also released oxygen. So in terms of describing and explaining the changes in the Earth's atmosphere, describe, you say what you say what's happened, so it's a what question, so what happened. And then explaining is a why question, so you need to say, why did that happen? So you always need to use the word because. So the levels of water vapour decreased, so that's my what happened, it decreased. And then what I need to do is I need to explain why. So water vapour levels decreased because the Earth's atmosphere cooled and it condensed to be water. So describe, you say what happens in terms of a trend. Explain, you say why it happened. So what I'd like you to do, I'd like you to complete the table. I'd like you to talk about the levels of carbon dioxide, oxygen, and nitrogen as well, please. So pause it for as long as you need to. So checking and correcting. Carbon dioxide levels have decreased, that's your description, because the carbon dioxide has become locked up in rocks and fossil fuels, and also has been taken in by plants during photosynthesis. So that's my explanation, because I am saying because. I'm explaining why it happened. So please make sure you've improved your answer in a different colour. And then do the same thing for oxygen and nitrogen as well, please. So, you should have also answered the questions below. If you haven't, please go back and make sure you've done that. And then these are very, very basic recall questions. So, when we're talking about exam questions, we've talked about this, but just in terms of describe, you say what you see. Explain is how and why, so it always includes the term because. And compare, you need to say what is the same and what is different. So you always start with what's the same, what's similar, and then you say what is different. You have to have a balance of the two, or else you will not get full marks for a compare question. So your first one we're going to do together, it says this question is about life, the Earth and its atmosphere. There are many theories about how life on Earth was formed. Suggest one reason why there are many theories. So a suggest question, you're coming up with your own explanation about it. It's not giving you the explanation in a graph or in a chart. You need to come up with your own ideas. So what we can think about here is the fact that the life on Earth we said was 2.7 billion years ago. Was there anyone there to prove that? No, obviously not. Do we have any solid evidence? Yeah, we have fossils, but we can't prove that it was the case. We can only support that theory. So you just need to put that we don't have any clear evidence. Obviously, there wasn't anybody around 2.7 billion years ago. So you would just need to state, because it's a 1-mark question, don't need to go into loads of detail. You just need to say, we don't have any evidence to support this. So any questions relating to something which is such a long time ago that there's no evidence to support that, always go with there is not enough evidence. So this question gets slightly more complex because we've got describe and explain in there. So describe, you say what you see. Explain, you say why. So it's asking us to both describe the changes, so say what you can see the difference between those two diagrams, and it's asking you to explain why in terms of the content that we've covered earlier in this PowerPoint. So what I would like you to do is I would like you to have a go at planning and answering this question. So it's important to know what happened and why. So if I pick an example, let's say in the early Earth, it was mostly covered by volcanoes. However, in the Earth today, most of the Earth's surface is covered with oceans. So then you would say why that is, in using the information that you've got throughout the lesson so far. So please rewind the lesson if you need to, pause it for as long as you need to, have a go at answering this question. So in terms of going through a model, what you can do now is you can compare your answer to this model and you can use it to help you improve going forward on a describe and an explain question. So different coloured pen, what you can say is the surface solidified, eruption of volcanoes decreased because the Earth cooled. So that's your description, it solidified. Why the Earth cooled. Oceans formed is a description. Your explanation is the water vapour condensed and fell as rain over time. Notice how I'm using the word because constantly, because that demonstrates that I'm explaining why. So carbon dioxide levels reduced, description, because it dissolved into oceans and was taken into limestone. You can also talk about fossil fuels. And it was also taken in by algae during photosynthesis. So that's my explanation. So oxygen levels rose because it was released during photosynthesis. So oxygen level rose, description. My explanation is it was released during photosynthesis. Please make sure you've improved your answer. Please go through and highlight where you've differentiated between your description and explanation like I have. I've underlined because for each one, and that demonstrates that I've explained it as well as described it. So, quick recall quiz of what you have covered in this lesson so far. What I would like you to do is I would like you to answer the 7 questions. Please try and do it without your notes. If you do need to use your notes, that's fine too. Pause the video for as long as you need to answer the questions, and we're going to mark them on the next slide. So please mark your answers to each one. So the 2 gases that were highest in the early atmosphere are carbon dioxide and water vapour. So number 2, the world's oceans and rivers were formed because the water vapour condensed. Please make sure you get that key word in there, cooled and it condensed. The process that removes carbon dioxide is photosynthesis. One way in which carbon dioxide was locked up, you could have had it dissolved into oceans, made limestone, trapped in fossil fuels, but you can't have photosynthesis for that one. Gas that makes up the majority of the atmosphere, we've got 78% nitrogen. We think that the Earth's early atmosphere looked much like Mars and Venus today. And then there's some uncertainty about the Earth's early atmosphere because we don't have any clear evidence because obviously it was so long ago. So please make sure you've marked and improved them. Give yourself a mark out of 7 if you wish. And then last extension task is I'd like you to do the exam questions in your booklet. This should take you about 15 minutes. If it takes you any longer, that's fine too. But please make sure that you mark them using the mark scheme which is in the continuity of learning folder for this week.